It feels like every single week there's a new GPT-4 killer hitting the scene, another model that claims it's faster, smarter, and way cheaper. But today we're looking at a contender that's not just trying to play the same game better, it's playing a completely different game. We are going to put MiniMax M2.1 through some serious tests to see if its radical new architecture can actually live up to its massive promises.
And that quote right there, that really gets to the core of it. See, most of the large language models you've heard of, GPT-4 included, they're all built on something called softmax attention. Well, MiniMax basically threw out that part of the playbook. They're using a fundamentally different brain, and it's called linear attention. Let's break down why that changes, well, everything.
So, what does linear attention actually mean for things like performance and cost? Let's get under the hood and look at the architecture.
Okay, the key difference here is all about complexity. Traditional models with their softmax attention have what's called quadratic complexity. And what that means is for every new word you add, the amount of computation needed gets exponentially harder. I mean, imagine you're in a room and to understand just one person, you have to listen to every single other person in the room at the exact same time. It would get out of control fast. Linear attention, on the other hand, is way more chill. It just processes information one step at a time, kind of like reading a book. And that is the secret sauce that lets it handle millions of tokens without even breaking a sweat.
So, what we've got here is a really brilliant mix of technologies. It's a mixture of experts model. You can think of that like having a whole team of specialized expert networks inside, and the model only calls on the right expert for the job. But the engine driving the whole thing is this hybrid lightning attention. It's mostly linear for that incredible speed and scale, but it has this clever dash of traditional attention sprinkled in. And it's all designed for one single purpose, to absolutely master these enormous, million-token contexts.
Having an impressive architecture on paper is one thing, right? But can it actually perform when the pressure is on? We decided to put it through a real gauntlet, a series of stress tests, to see if this new kind of brain can actually think, remember, and reason over these huge distances. First up, a pure memory test. We're talking about the classic needle in a haystack. Can the model find one single specific fact, the needle, that we've buried deep inside a massive sea of totally irrelevant documents, the haystack? This really tests its raw retrieval power at a massive scale.
And the scale of this challenge is just insane. We're not talking about a couple of pages. We fed it 2 million tokens of really dense information. That's basically like asking an AI to find one specific sentence inside a stack of books that's 5 feet tall.
But hey, memory isn't everything. So next, we tested its logic. Can it actually understand complex relationships and keep a coherent train of thought across a huge, messy codebase or a bunch of technical documents? This is where a lot of these long context models just completely fall apart.
So the gauntlet was set. The tests were run. How did MiniMax M2.1 actually do? All right, let's get to the results.
Okay, the results from the needle in a haystack test were absolutely fascinating. You can see that a model using purely linear attention, well, it struggled. It struggled badly. But MiniMax's hybrid approach, the one that mixes in just a little bit of that traditional attention, it didn't just match the old method, it actually did slightly better.
So this isn't about just replacing the old with the new, it's about combining them. What the researchers figured out is that while linear attention is amazing for efficiency, it can struggle to find that one specific detail. But by adding back just a tiny bit of traditional attention, they created something that has the best of both worlds, the incredible speed of the new with the pinpoint precision of the old. And on that logic test, it passed with flying colors. I mean, the model showed this remarkable ability to follow really complex instructions, refactor code, and summarize arguments that were spread out over hundreds of pages. It proves this new architecture isn't just about remembering things, it's about genuinely understanding them. So, it totally passed our stress tests. It proved its new architecture really holds up. But performance is just one piece of the puzzle. What does this mean for you in the real world, and what else can it do?
Because, its performance on text is only half the story. MiniMax has a serious ace up its sleeve.
This is where it gets really, really powerful. This model integrates a vision transformer, which basically gives it eyes, turning it into a true multimodal engine. So it doesn't just read your email. It can look at a screenshot of your entire inbox, see the pinned messages, identify the calendar invites, and then logically figure out what you should probably do first. It can see and reason about the visual world around it.
This kind of capability just fundamentally changes the game.
We're moving way beyond just text in, text out. This opens the door for incredibly powerful new uses in visual data analysis, understanding documents, and building systems that have a much richer, more human-like grasp of information.
All right, now for the final and maybe most critical piece of the puzzle, the economics. All this power is great, but is it actually practical? Well, this all comes back to speed and efficiency, which is where that linear attention architecture really starts to pay off.
I mean, the proof is right here in the raw throughput numbers. When you compare it to other hybrid linear architectures, MiniMax's approach just processes way more tokens per second. And that translates directly to faster results and lower cost to run, especially when you're doing bulk processing jobs.
So, what's the final takeaway? My recommendation is this. MiniMax M2.1 is an absolute powerhouse for any task that involves huge amounts of text. I'm talking summarizing entire research libraries, analyzing legal documents, or engaging in really long-form creative writing and roleplay. For those things, its context and speed are a game changer. Now, for the really precise, mission-critical stuff like complex math or high-stakes coding, you might still want to lean on a model that's been fine-tuned just for that level of accuracy.
And this leaves us with a final thought, right? MiniMax M2.1 is a spectacular achievement, but it also highlights this bigger trend we're seeing. Maybe this whole quest for a single GPT-4 killer is missing the point. Maybe the future of AI isn't a king on a throne, but more like a garage full of specialized tools, a whole council of AIs, each one designed to be the absolute best at its own specific job.